So let's start off with making some simple parts that we can use to practice some of the advanced mates for CSWP. I'm going to apologize in advance that I don't think this video is going to be very good. So just throw that out there. I'm going to use the just the center point rectangle tool. I'm going to make a base to put some of this stuff on. And I'll make it 5 inches wide and 1/4 inch tall. And I'm going to make it 2 inches wide. So it's 5 by 1/4 by 2. If you guys want to follow along, I'm just going to double click that and leave it on the screen for a few seconds so you can see what the dimensions are. If you're watching this on the video, you can always pause if it's that was too quick. I'm going to make a mounting point on one side that is then going to drive a gear attached to a different mounting point on a shaft on the other side. And then I'm going to have that turn an arm, which then follows a contour on the opposite side so we can put as many different kind of crazy mates in this thing as possible. Sound good? All right. So on this side, I'm going to do a tombstone sketch. Just going to have it come up. Trying to have it come up. I just lost the Model Mania right there. Because I took more than 5 seconds making that tombstone shape. Nah, I just did it. I mean, you had to sit there and wait for it to open, right? Like, what are you gonna do?
Single miss.
No, I mean, if I had seen that part or known what the geometry was, or I definitely didn't have like, no 0 misclicks kind of thing, right? Like there were definitely misclicks on there because I was trying to think as I'm sketching, which is always hard. All right, so I've got one tab there. I'm just going to pattern that to get a second tab. And I'll make them just 1 inch apart. I don't want 20, I just want 1. I guess I want 2. I want 1 extra 1. So that's where I'll put my first one. And then I'm going to pattern it again, but in the other direction. And I guess for funsies, let's do a double direction pattern and then skip instances. So this is something that's kind of fun to do, is I can pattern that out. Oh, that's too wide. It's 2.5. So I can do something like that. And then I can come down here and I can do instances to skip. And I can say which ones I want to keep and which ones I don't. So if you want just like an offset part in 2 directions, you can pattern it and then just say, hey, yeah, I don't want those ones. Does that make sense, everybody? Another thing you might want to look at is also instances to vary. So if I wanted to make the hole bigger on these ones, maybe I can't skip instances and vary instances. I don't know, whatever. But you can also make the features bigger or smaller as part of the pattern. So that'll work kind of okay, I guess. And then what I'm gonna do is I'm gonna make a shaft that has a gear on one side, and then I'll modify that gear to make another one. And then we'll use a gear mate to actually run that. These are not going to be good gears. Just we've talked about in the loop gears in this class before, and how making the appropriate geometry for a gear is not a trivial matter. So just keep that in mind. Just these are not good gears. These are just going to be the fastest gear we can make. So I'm just going to define a circle. I don't even know how big this should be. It's going to be the wrong size because I don't know. I made them like 1 inch apart. So I guess I can make one have a radius of like 0.25 and then one have a radius of 0.75, and hopefully they'll mesh. So this one, if I want a radius of 0.25, I'll just do 0.5 divided by 2, 0.125. I'll extrude that out to 1/4 inch. That seems really tiny. Let's try it anyways. I'm going to sketch on here to put some teeth on this guy. And Yeah, I'm just going to freehand some teeth. So I'm just going to draw a trapezoid. And I don't think I'm even going to define how big this trapezoid is. I'm just going to make a tooth. I'm just going to let it be freehand just to save time. To make it look a little bit nicer, I'm just going to offset the start. And I'll make this 0.1. And this might help us to do some selections too. And then I'm going to pattern that tooth around. So I do a circular pattern. It didn't intuit what I wanted. Come on, SolidWorks, you're better than that. I'll do, I don't know, 10 teeth. I'm just going to save this as gear 1. And I'm just going to edit it. Make this diameter half of 0.75. Oh, sorry, I got to do that. Just going to double click. 0.75 divided by 2. I'm going to rebuild. That probably puts my tooth inside that part. So I'm just going to edit this sketch and drag this guy up. I use the selection box to select the entire sketch so that when I drag it, it doesn't change the size of any of the sketch. If I just click on one part, notice how it kind of messes things up. So if you need to move a whole sketch, just drag over it and then move it around. I don't know, can you control click to make copies like this too? You can. Haha. Good on you, Jose. I'm not sure how much utility that has inside of a sketch, but you can do it. So I'll use the same tooth size because that's fine. And I do need to decrease the number of teeth on here. And again, I feel the need to continually express the fact that don't make gears like this. And we don't need to have central shaft because SolidWorks doesn't care about, things actually working the way they're supposed to. So I'll save this as gear 2. And I'll start making my assembly just so I can see where I'm at on this. So let's import our gear 1 and gear 2 into here. Actually, I gotta make this into assembly first. Save and insert. Yeah, we'll call this, I'm gonna call it base 2. I already have a base 1. If you just want to call yours base, you can. Or plate or mounting plate or whatever. Always click on that green check mark. Hopefully I don't even tell you guys that. But when you're making an assembly, you want that first part to have a fixed starting point. I guess we should talk a little bit about moving around parts that it doesn't start on the origin because you can get thrown off. If you want a part to not have the same orientation location as it is by default. Patrick, what are you doing? Eating in my classroom. And that'll be forever safe for posterity. I forgot what I was doing. So if you want to put this in a different spot, you can float it. And then you can come in, you can mate the reference planes into different alignments. So you can put the front plane on the top plane. So that way the orientation of the coordinate system is however you want it. I don't actually suggest you do that. I suggest you start off with that align. And if you need to measure relative to a different coordinate system, make a new coordinate system, usually a lot faster. So if I go into where am I? Here, reference geometry. I was looking, I couldn't find it. Coordinate system, say I want a coordinate system on the corner of this rectangle, easy peasy. There you go. Different axis directions, there you go, right? And then if you want the center of mass relative to that coordinate system, you go to evaluate, mass properties, and you say, what coordinate system do you want? I want my coordinate system 1. And now it's relative to that coordinate system 1 as opposed to your default coordinate system. You didn't have to move a bunch of parts around. If you make the whole assembly and then you realize that the coordinate is not in the right direction, like it's flipped, it's going to the left instead of the right, just make a new coordinate system that goes in the opposite direction. Problem solved, right? It's like the delete face version in assemblies. I got to the end. I realized I made a mistake. How do I fix it without remaking the whole part, right? So it's something you can do. All right, let's get into our other parts. I'm just going to drag them in from the desktop. So I got my gear 1, my gear 2. Again, these don't actually have to fit in place. I'll put my gear 1 in the middle of these 2 parts. So a very common mate that you'll see and is just super helpful in general is like the tab and slot mate. I don't know if it's actually called that. It's called the width mate. And all you do is you specify which one is the tab and which one is the slot. It doesn't matter which one is the tab and which one is the slot. It's always going to center align it. So I click on 2 sides of one part, 2 sides of another part, and that part is now perfectly centered between those 2 pieces. Again, it doesn't matter if I flip them. So I could say if this one be the width. I don't know if I'm actually flipping it or not. I think this is the opposite order I just used. Same exact mate, doesn't matter. If you want some face to be symmetric as opposed to having a width, then it's just the symmetric mate instead of the width mate. So I gotta delete that one. I could put this face in the middle of these other parts by clicking on them like thus. Oh, I only got one. Why did I only get one? There we go. Now it's in the middle. Now that face is in the middle of those 2 parts. So just to align things, those things are pretty straightforward to use, right? I'm going to accept that. I'm going to go back to my standard mates and I'm going to make them concentric just so it's kind of lined up with my holes. And we'll use the same thing over here, make you concentric. And I'll use that width mate again to put this gear in the middle of my parts. Oh, wrong selection. Don't use 2 different parts for the width. It's the 2 on the same part, the 2 on the same part. There you go. I don't know how I got the difference between the sizes of those so far off. Maybe I actually made these ones in millimeters. I don't know, but whatever. All right, next thing we'll talk about is the gear mate. So this one here, every time that rotates, this should rotate more. And it's like a 4-to-1 or 3-to-1 because it's 0.75 to 0.25, so it's like it's a 3-to-1. The gear mate will automatically decide on gear ratio based off the size of the selections if you let it. You can also manually override it to have it be whatever you want. So if I come into the mate tool, go to mechanical, and click on gear. I can click on the cylindrical face of this gear, the cylindrical face of this gear. You notice it specifies the gear ratio based off those selections. This is just rounding. It's 0.125, 0.375. And then I can click on that. And now when I move it, you can see that they move. It's a little hard to tell, but the bottom one is moving like almost a whole rotation already. They move in line. If I had made these closer to the right size, then they would have meshed better and you could see that they actually work. If you want them to move in the same direction on the mate, you can reverse and it'll go the other way. You can also just make this whatever you want. A lot of times if you have like the number of teeth, which is actually what's going to drive the ratio, you can say this is like 10 to 1. Doesn't matter what the unit is. It doesn't have to be the same size of the part. It's all about the ratio, right? So now this is a 10 to 1 ratio. And you can see that a tiny movement on here moves that other one a lot. Whee! It's a little hard to tell because it's moving so fast that you can't really see the teeth displacing, right? If I move this one, you can see that moving this one a bunch only moves a tiny amount on the other one. So pretty straightforward. Questions on the gear mate? All right, let's modify this part. Keep in mind, you can always modify parts in the assembly. You don't actually have to open the parts to modify them. And it will save across both ways. So if I take this base and I edit the part, I have to save the assembly first. Yeah, whatever, just save as assembly too. Now anything I do inside here is going to change the part and not the assembly. Be very careful with this. If you make a sketch, so for instance, I'm going to go here and I'm going to sketch on the front plane. I could sketch on a plane in a different part on here. And now I've forever locked those two parts relative to each other. And changing one is going to mess up the next one. So just be real careful about what you're doing with this. I recommend that unless there's a reason that you really need to edit that part inside the assembly, because you need to see how it's aligning relative to each other, don't do it. Just do it as a separate part because you're less likely to make issues. Also, I don't know how many times I've seen someone go and they're trying to make a sketch in this part and they click on front plane and they click on sketch and they don't realize that they've made a sketch in the assembly just using that as a reference plane. It's actually telling me like, hey, you're sketching in the assembly. Did you want to do that? That sketch is not inside that part. It's just on the front plane of that part in the assembly. So if you want to edit it in the assembly, you can. There are advantages. Make sure you edit the part. Make sure that you're using the appropriate references. If you're using the front plane of the part as opposed to the front plane of the assembly, et cetera, et cetera, et cetera. Sound good? All right. I want to make a spline for this guy to follow. Yes. So I'm just going to go to features. I wanted to sketch. And I'm going to do spline. Because if you're going to follow a path, you might as well follow a spline. Except for I may regret this because, again, doing things ad hoc like this is not always a great idea. I want to extrude this out just because I feel like I should have a thing for it to follow. 0.5. Although I don't need to have that as an option. I thought I mid-plane extruded that. Why am I thinning? Oh, I messed up. My contour is not closed. I need to go to my old friend, the power trim. There we go. I'm just going to do up to next. Up to surface? I guess up to surface. There we go. I've got a nice little hill. And then I'm going to make an arm as a separate part. You can also make parts directly in the assembly. So I do insert component. Oh, sorry, the drop down next to insert component, new part. Now I have a part. This part is embedded in the assembly by default. It's what's called a virtual part. So it doesn't exist as a separate part, although you can make it real after you've made it if you want to separate it out, just in the save options. So I'm going to make this part here. I'm just going to sketch on its front plane. No, I see I did the same thing. I didn't edit the part first. I'm going to edit the part. I'm going to sketch on that part's front plane. And I'm just going to make a slot. And I'll have it go like that. And I'm going to extrude that out. I'm just making a link so we can use that. And then I'm going to use the Jose method to make a copy of it. And I'll mate this guy here. No, I don't want the edge. With my gear. And I'll put the end of it there, concentric. Why aren't you moving? Oh, I did something wrong. What did I do wrong? No, it doesn't need a hole. I can have interferences. Interferences are fine. Oh, it's fixed. I gotta float it. If you have fixed parts, you can't move them. Just, I don't know if that needs to be said, but it's necessary. So I'm gonna mate this guy onto here. That would have definitely cost me my exam, right? And I do want these two parts to rotate with each other. So what I'm going to do is I'm going to use the, let's say the top plane of my part 9 And then my gear 2, I'll use, that's still part 9. I want gear 1, I guess, the little one. Yeah, let's use the front plane. I'll make those together, just make them parallel. Coincidence factor, I guess. All right, so now when I move this gear, oh, it didn't work. Why didn't it work? I want you to rotate together. Did I not accept that mate? I guess I didn't. So you can use these reference planes. I want my gear to rotate with my bar. I hope it's not because I didn't define the, it probably is. Now you'll go. There we go. Whee! Fun. Okay. And I'll mate my other, not that face, my other link on the end here. Hopefully this will make sense as to why I'm doing this at the end, is I want the links here to follow the path of my little hill. Yeah, I don't know what I did wrong. I'm reasonably confident it's because I made these parts inside the assembly and I didn't fully define them. I was just trying to be too fast and too loose. I'm just going to get rid of some of my other mates and try and make this work again, because I want to show you guys the path. Can I move this now? We good? No, still not good. No, I don't want to give it that one. Sure, give it that one. That one's fine. I did want to drive it all based off of the gears, but that's okay. All right, I just mate you on the side just so you stay put a little bit. Don't complain. Yeah, okay. So it's not going to move with our gears, but we can still make this part follow this part here. So let's go to our mates. We can go to our advanced mates and we can specify a path. So we want a vertex that we can use. So we can use any point, and then the path, usually you're going to use a sketch. So on my hill here, actually, I'm not sure if this will work because it may not work because of where my sketch is. On my boss extrude, no, this is not, here's my base here. I have this guy. There's a path there. Yeah, it's not going to let me, can I do a projection on this? Yeah, it's not going to let me do that because they don't line up. We'll break it. Let's do, I'm going to break this coincident mate that I defined. And then hopefully let me redo the path. No, I didn't add it. All right, come on, maybe. We can do it. Really, the only reason you would want to do this is being able to control this. So I want that point to go on that line. There we go. So I have a point in a line. And right now, it's just going to follow that line. You see that? And you can use any point in line that you want. And sometimes you have to modify the part to add a point in a specific location or to make an intersection to make a specific path. This is a bad example. Usually if you wanted to do this, you would have a more complex three-dimensional path. This is just along a constant curvature, but you can imagine that could do like a wrap, right? Of a spline onto a circle, and that wouldn't work with just like a tangent constraint or something like that, right? Or you have a really complex cam or something that you want to do, although there's separate mates for cams that you should use. Anyways, you can do that. On the CSWP, the way they're going to try and get you with this is that on the path mate, you have these options for how far along the path do you want to be, right? So there's this distance along path option, and you can say like, how far along the path are you? And that's something that's really hard to measure and just kind of like guess at. So it allows them to say, hey, I can give you this convoluted mate with this very specific input, and then ask you if you got the right value or not. So that's what they're going to try and get you. It's going to be distance along path or percent along path. They'll start off typically with set this up the way we have it set up. And you'll think, oh, well, I don't actually need a path mate to do that. And then they're going to follow that up with change it so the percent distance along path is blank. And you're going to be like, I got to go back and make the path mate. So if they ask you to make a path mate, expect them to follow up with put the percent distance to this value, right? And again, it's not hard. It's just the fact that I didn't have a path and a point set up to do this with at the start. Does that make sense, everybody? Or at least most of you? Yeah, I think we're out of time. So hopefully that's valuable. If you guys have other questions, if you have things you want to share with the class, then let's do that real quick. If not, then we'll call it a day.